So we have found the general solution for the wave equation, and the wave equation was dou square u by dou t square is equal to c square into dou square u by dou x square, with the initial conditions u0 t equal to 0 and ult equal to 0, and ux0 is equal to f of x, the initial position, and utx0 is equal to g of x, the initial velocity. And by employing these two conditions along with the wave equation, we have derived the general solution of the wave equation. And the general solution that we obtained was uxt is equal to sigma n equal to 0 to infinity an cos n pi c t by L plus bn sin n pi c t by L times sin n pi x by L. So this was x of x into y of t. Okay, I'll just find the derivative of u also with respect to t, because I want to apply the initial conditions of initial position and velocity. So I may need the velocity. So you dou u by dou t, if you find, you take the differentiation inside the summation. So it is sigma n equal to 0 to infinity an into minus sin n pi ct by L into n pi c by L. That's the derivative of this expression in t, plus bn into cos n pi ct by L into n pi c by L. That's the derivative of sin n pi ct by L. That much into sin n pi x by L. And here you should note that this will not be differentiated because the derivative is with respect to the independent variable t, and it's a partial derivative. So this function will not be affected by the partial derivative. Now our aim is to find what is an and bn, and for that we can use the information that the initial position is f of x and initial velocity is g of x. Now we are trying to find an and bn. Now to find the constants an and bn, we put the two conditions, that is u of x0 is equal to f of x and ut of x0 equal to g of x. The wave equation was having four conditions. These first two were used for finding the general solution. Now we are left with these two conditions, and these two will be giving you an and bn. The initial condition ux0 equal to f of x gives f of x equal to sigma n equal to 0 to infinity an sin n pi x by L. Now this is obtained by just putting t equal to 0 in the general solution of the wave equation. So here I am putting this equal to 0, this t equal to 0 and this t equal to 0. So this entire term will vanish. And here what I am getting is an into 1. Cos 0 is 1. So an into 1 sin n pi x by L is equal to u0 t, which is f of x. That's why you are getting f of x equal to an into sin n pi x by L. Now if you observe, you can see that the function f of x has been written as a series of sine function. So this is nothing but the function f of x expressed as a sine series. F of x expressed as a Fourier sine series. So f of x is equal to sigma an into sin n pi x by L. So what are this an? An can be easily found in terms of f of x using the Euler formula, right? So according to our Fourier series theory, this an is equal to 2 by L integral 0 to L f of x into sin n pi x by L dx. Okay, so from the Fourier series expansion, actually what we are getting is turned out to be a Fourier sine series, and from the theory of Fourier sine series expansion, you can see that the coefficients are nothing but 2 by L integral 0 to L f of x sin n pi x by L dx. This has been explained in the prerequisites. Now the second condition says that the initial velocity is g of x, that is utx0 is equal to g of x, and this, as in the case of ux0 equal to f of x, this gives us g of x is equal to sigma n equal to 0 to infinity bn n pi c by L sin n pi x by L. In order to get it, you can just put in the expression of utxt as a series, you can put t equal to 0 here. This t will become 0 and this t also will become 0. So what happens is this entire term will vanish, whereas this will be having bn into n pi c by L sin n pi by L x. Okay, and g of x is what results in the left side. Like if you put t equal to 0, you are getting the initial velocity, and that is assumed to be gnx. So gnx equal to sigma n equal to 0 to infinity bn into n pi c by l sine n pi by l x. And when in n equal to 0, there will not be any term because sine 0 equal to 0. So what is this? This is just the expression of g of x as a sine series with the coefficients bn into n pi c by l. So what it says is g of x has a sine series expansion expressed in this way. So what should be the coefficients? The coefficients are not bn. Coefficients are bn into n pi c by l. These coefficients must be equal to the Euler formula, that is 2 by l integral 0 to l g of x into sine n pi x by l, n pi x by l dx. So that's how you can find bn. Thus bn into n pi c by l is equal to 2 by l integral 0 to l g of x into sine n pi x by l dx. So this l and this l can be cancelled, and therefore bn is equal to 2 by cn pi integral 0 to l g of x sine n pi by l x dx. So you got bn as well as an. So the equation 12, which is this expression with an equal to that expression using the sine function, and bn given here forms the actual solution of the wave equation. An equal to this and bn equal to this. Bn equal to 2 by n pi by c. Next equation, this equation. Okay, so that gives you the complete solution of the wave equation. Thank you.